guys, Mrs. Traver here. Today we're going to end chapter 7 by looking at multiple representations. Our learning target for today is that you'll be able to write equations for exponential functions when we're presented with graphs, and you'll be able to look at an equation and a graph in the same way. Let's jump in and let's talk about all the ways we can represent a function at this point in our learning. So there's a table with a table of values, x's and y's. We have a graph which shows it on the linear plane. We have equations like y equals a times b to the x, and we have the situation it all represents. And these are all connected is kind of where we're at. The game plan today is we're going to do 4 problems, one where I give you one of these things and we find the rest. The first one, I have the graph given to us and I want the table, equation, and situation for it. So I can tell on this graph there are some points that I can notice. There's a point here at 0, 16,000. I'll put that on my table. There's also a point here at 1, 14,000. And I noticed that the graph is not moving in a linear fashion. It's curved, so that means it must have an equation that is exponential, like y equals a times b to the x. So therefore, I'm looking for a multiplier. I can fill in the last spot of my table if I can figure out that multiplier. It went from 16,000 to 14,000. So I could solve for b by dividing those two. 14,000 divided by 16,000, I can reduce. All the zeros will cancel, and 14 over 16 will reduce to be 7 over 8. So I'm multiplying by 7/8 each time. I just found my b, and I can just find my next one if I use 7/8. Let me grab a calculator. First, I'll put in 7/8 to get my decimal, and then I'll multiply by the last number I had, 14,000. My next number should be 12,250. Whoops. Let me go back, 12,250. Okay, and then my equation I can finish out. Y equals, it starts with the y-intercept, which is 16,000. And it multiplies each time by 7/8 to the x. So there's my equation. Lastly, we have to come up with a situation for this that would be reasonable. And I can tell that this is in years. So it's something that starts at 16,000 and goes down over time. It doesn't tell me what the relationship with y's are, but I usually like to think about money for these things. So maybe it's the value of something that costs $16,000 and it goes down over time. Maybe this is the value of a motorcycle. They actually value decreases less than it does per car. So maybe this is the value of a motorcycle over time. But again, I don't really know what it is. I'm just taking a guess. CYCLE over time. I'm just taking a guess with the reasonable situation we have on our graph. Let's try another one. This time I'm given the equation, but I'm not given anything else. So let's use this equation to set up our graph. And I know that I'm starting at 180 because it says so. That's the A term. And I'm multiplying by 1.22 each time. So I'm going up by 22% each time. So I can say times 1.22 for my first one, and then I'll do it again for my second one. Let me grab that calculator one more time. So I've got 180 times 1.22 is 219.6 for the second one. So 219.6. Let's just say 220. We'll round. And then times 1.22 again is 267.9, or about 268. All right, so we're good with our table, we're good with our equation. Let's make our graph at this point. Move this calculator out of the way. We have to get to a height of, with our graph, we have to get to a height of at least like 270 or so. I've got 20 spots, so if I count by, what can we count by? Maybe let's go to 300. That's a nice even number, and I have 20 spots. If I count by 15s, that will work. So this one will be 15, this one will be 30, this one will be 45, and then 60. Really, I'm just going to write every other number and count by 30s at this point. So let me fill in the rest of those. 150, 180, 210, 240, 270, 300. Okay, and then for my x-axis, I'm just counting by ones, but if I use 1, 2, and 3, it's going to be really crammed. I'm thinking I could spread it out a little bit on the bottom, and maybe I'll skip 5 spaces. 1, 2, 3, 4, 5. That'll be my 1. 1, 2, 3, 4, 5. That'll be my 2. Okay, I'm ready. Let's plot our 3 points that we have. The first one is on the y-axis. It's 0, 180. So there's a point for us. The next one is 1, 220. So it's going up. So here's 210. Here's 225. So a little bit right here-ish. I'm estimating as best I can. The next one, 268, so that's almost 270, right under that line. 268, yeah, there we go. So I've got something like that. It kind of looks like a line, but my graph's a little smushed. A situation where this could happen, let's see, something that starts at 180 and goes up by 22%. This could very well be a credit card bill, actually. The way credit card bills work is you spend $180, and if you don't pay it back immediately, they will charge you that $180 that you owe back, plus an extra 22%. So like if you didn't pay it within the month, then you owe $220. And if you didn't pay it by 2 months, then now you owe $268. But remember, you only ever charged $180. So if this was a 22% interest rate, then this would be your situation. And honestly, this interest rate is pretty realistic to some credit card companies. Let's try our last one. I'm going to skip this one and do this last one with the situation. It says currently there's an estimated 1,800 trout in a lake, and an infection caused the rate of fish deaths to be 1/3 of the population per week. So our table I can set up with my X and my Y. We know that we started with 1,800, and, oh, I'm sorry, we know we started on day 0. Let me put a 0 up there. I got a little ahead of myself. We started on day 0 with 1,800. On day 1, it got cut in thirds, so really we're like dividing by 3. That'd be 600, and then if we cut it and divide by 3 again, I'd only have 200. My equation I can write now from my graph, it'd be y equals, starting at 1,800, and then getting cut in thirds would be multiplying by 1/3 for every x. I think I'm ready for my table. If we count by hundreds, we'll get up to 2,000. So I think that'll be good. So 100, 200, 300, 400. I'm going to count every other one and write that one, or else it gets kind of cramped on my paper. Or my slideshow, I guess I should say. 1,400, 2,000. These numbers represented the number of trout. And then down here, it said per week, so these will be our weeks. And we're only going to need up to 2, so I'm going to spread it out again. Here's 1. I'll take another jump before I do 2. All right. I think we're ready to plot it. We've got our original amount, which was 1,800 way up here. And then it got divided by 3 right here, 600 left, and then divided by 3 again right here. And I can write my line in. There it is. I think we're all set. So as you can see in this lesson, we've kind of connected all the pieces. We've dealt with tables for a while, we've dealt with equations for a while, we've spent some time with graphs. Now we're putting it all together. I hope this makes sense, and I will see you next time. Bye, guys.